Okay, the first thing in preparing to put a 3-link into any of the RRS applications is axle housing prep. So there's a number of things to consider with this. If you're using your own second-hand centre, you need to make sure the surface where the torque arm bolts up is a machine surface. Some of them have rough cast. This is not good enough. You have to stick the pinion housing into a lathe and machine it flat and parallel. Otherwise the torque arm won't line up properly. The next thing is to run a tap into all the threads. Make sure that there's full thread engagement for all of the securing bolts for the torque arm. Otherwise something could work its way loose or not bolt up securely and cause damage. So now we're going to put the torque arm on, tighten up the shock mounts, put the trailing arms on. That's axle housing prep completed and ready to roll underneath the car to mock up. I always do a preliminary mock up with everything first. Okay, let's do it. Not everything is a precise thing on these axle housings, so we fit the easiest bolt to go in the holes first. Just tighten it enough so it just contacts the torque arm. Just nipping them as we go until we get everything in place. Don't force anything. Then start doing opposite bolts. And then when we've got them all in place, then we do the final tighten up. Next step, I bolt the lower shock mounts into place. Okay, and a liberal coating of grease before you put the trailing arms. Trailing arms in next. And these arms are offset to allow for bigger tyre clearance. I prefer to put the bolt this way from the inside out for the reason that it makes it, if you have to change any of the positions, it's easier to get in and out. Next thing, upper shock mount frame. After you've removed the factory pinion snubber, bolt this into place with the 2 large bolts supplied and the washers either side of the shock panel. Then you re-drill these holes through the panelling and then install the load spreader plate as shown you. Next step is we hang the shocks, put the bolts through. Again, we're doing a mock-up, so we just put everything in loosely, but don't forget to tighten up everything afterwards. In early Falcons, Comets, Cyclones and Falcon Sprints, you use the original spring eye bolt. Now there's 2 different sizes in the shank. If it is not the larger size, we provide a sleeve that makes the bush fit properly. We're just hanging the shocks at this point in time because once all the 3-link is installed with the front cross member, we may have to shim the shock absorber backwards or forwards with the supplied shims to get the alignment angle correct. So far we've attached the torque arm to the axle housing, fitted the trailing arms, mounted the upper shock mount frame and mocked the shock absorbers into place. Now we're going to double check tyre clearances, then we're ready to put the Watts link in and the front cross member. So this particular swap is using a 5.4 32 valve quad cam Boss motor. It's also using a ZF 6-speed auto. I always recommend that the engine and transmission is fitted prior to setting up the 3-link. The reasons for this are really simple. Setting up drivetrain angle. Absolutely vital in any car. One of the big problems that I see all the time is when people put a manual 5 or 6-speed transmission. They don't modify the tunnel, they drop the back of the motor right down, you end up with a 5-degree or more engine drivetrain angle and you end up with a tail shaft vibration or limited life on your universal joints. So there's optimum angles for this. So first of all we get the motor set ideally at its right angle for a Ford, which is 3 degrees to the centre line of the car, and On this particular one, we've incorporated a rear gearbox mount into the 3-link front crossmember. You'll see that we've removed the gearbox original extension housing that has the mount incorporated in it, and this is one that we make from RRS to make it nice and simple to bolt into just about any Ford chassis. It's part of our transmission conversion swaps. It's an option that you can have with our 3-link. So the line-up points to put the front cross member in are fairly straightforward. There's a fold in the floor, try and bring it back close to that, so you expose the hole in this subframe rail. Now this subframe rail is unique to Australian models. The Australian versions of an early Falcon have a subframe here. The US models don't. The chassis rail actually ends about this point. So on the Aussie one, we pick up the cross member going back. On the US one, we pick up the cross member going forward. You bring your cross member close to this crease. It's as simple as that. And make sure that there's enough room for the front bolt to go through the frame rail. They can be fairly snug in here. Board tolerances weren't the best. Added to that, if it's had rust repairs, we spent a fair bit of time making sure all this was lined up. I have had cases where there's been Mustangs, they've had the floor repaired and welded the floor to the outriggers, these sections, all over to one side, and then it puts all the alignment of the torque arm out. So you have to pay attention that these things are square, equidistant from the centre line of the car to the outside edges. So we've pre-drilled these holes, we'll now bolt it up, and then I'll show you how we install some crush tubes, because it's very important to have 2 directions of anchorage. Adds a lot more strength to it. So vertical, horizontal. In your RRS 3-link kit, you'll have 2 of these load spreader plates to go through the floor. Depending on which model, there'll be different size and different number of holes, but this is applicable to this model. So we've got our vertical bolts in place. Now we'll drill our crush tube holes through here for a clearance with a 3/8 UNC bolt. Then we drill a bigger pilot hole, this size, from that side only. Because the whole idea is that the tube goes in, clamps firmly on the chassis rail. You can weld this part into the rail if you choose after you've bolted it all up, but it stops the rail from crushing. So now we've got our front cross member permanently bolted in place, our torque arm sitting in place with the link set vertically. This is an approximate setting at the moment until we get our diff squared away at the back. So next thing is to fit our Watts linkage frame. Okay, so now we're sitting the Watts linkage frame in place. Adjust it forward so that we've got nice and snug in the rails, but also so we've got adequate clearance between the Watts linkage propeller and the pumpkin. We've drilled a pilot hole for one side, then we'll get that sitting in place, go over to the other side, make sure we've got it nice and square. Okay, so now we're attaching the Watts link attachment point to the axle housing. We just leave it loose for the time being so that we can line everything up. So we've got the Watts linkage propeller mount attached. We've got all of the bolts securing the frame solidly into the chassis and now becoming part of the chassis. Load spreaders are fitted. So now we're about to set up the Watts linkage rods. A preliminary set on the roll centre. I always like a car with a heavy front weight bias to be about 1 inch below the centre line. This is a good starting point depending on your driving style of the centre line of the rear axle at ride height. So this is just a starting point. After that you can adjust it to where you want. Okay. Next we screw on the Watts linkage arms. I always set them about halfway to begin with. See how things are lining up. You need the propeller at the vertical position. Plenty of grease on the rubbers, stacks, because the next thing is to make sure that this holds the diff with equal spacing either side. So you can adjust it over one way or the other. Now we're aiming to get the propeller mount vertical. Also at the same time get the differential so that it's square in the chassis. In other words, the distance from your axle face to your, whether it's your chassis rail or outer guard, you can adjust this to a certain degree. This particular one, the axle housing is sprung over that way by 3 millimeters, so I want to be able to pull it back in this direction. The way to make this adjustment is leave it so that it's got the equivalent amount that you want to pull over behind this mounting bracket, and when you tighten that up it'll pull the diff that direction. If you want to go the other way, you can adjust this rod, or vice versa, slacken one off or load one up. It's a little bit of experimentation, and once you've got the knack, you can set everything. So you're aiming for a vertical plane in that, a linkage that's up, down position, and once it's set at ride height, these should be sitting parallel, which you'll find when this gets a fuel load and all its windows, it will be. And the other thing now is just to make sure everything is in line. These rods need to have the same pivoting plane, so they need to be in the same vertical plane as the Watts Link propeller. Lock nuts. Watts linkage in its preliminary setup. Last thing, we're just setting the shock absorber spacers so that we've got an equal amount of articulation at the top and the bottom. And there we go. So now our installation of the 3-link is almost complete. This is a preliminary setting of both pinion angle, Watts linkage position, ride height, shock absorber angles. All of this needs to be checked when the car is finally finished. And we'll go through the adjustments that are required to get it absolutely spot on.